All right, in our previous in part one, we configured IP addressing for the PCs, and also we configured IP addressing for the router interfaces. Now let's try to ping PC2 from PC0. We want to see if these two devices, let me get this, if these two devices can talk to each other, these two. So let's do a ping. So if you do a ping you come to command prompt, and then you say ping. The IP address of PC2 is 192.168.1.130. This is the IP address of PC2. That is the IP address of this PC. So we are pinging that PC from PC1 because we are currently on the CMD of PC1 or PC1's terminal command prompt actually. So if you press enter here, you can see there's communication between those two devices. Why? It's because they're in the same network. Now let's try to ping still from PC1. Let's try to from PC0. From PC0 here, let's see if we can ping PC1. So let's get the IP address of PC1. PC1 is this PC over here. To get its IP address, you can say IP config, and its IP address is here, 192.168.1.1. So we want to see if we're able to reach this PC from PC0 here. So let's send the ping. So ping 192.168.1.1. So if you send that ping, let's see, the first packet is timed out. The second packet as well. The third packet is timed out, and actually the fourth one will be timed out as well. As you can see, that we can't ping PC1 from PC0. So as it stands, the guys in admin department can't talk to the guys in marketing department. And the reason for that is simply because they are on different networks. So if they're on different networks, for them to talk to each other, then what needs to happen? Traffic needs to go to the switch, then to the router, then the router needs to forward it to this switch, then from this switch it needs to go to this PC, and then the PC will respond, and that in response, the traffic should follow the same path. But currently, that one is not happening. The reason as to why that is not happening is because we haven't configured gateway on these PCs. We didn't configure gateways. So we now need to configure gateway so that if this guy wants to talk to other networks outside its network, then it is able to send traffic to the gateway address. So now let's configure gateway addresses to the PCs and fix that first issue there. So to configure, you just come here. The gateway address here is now, you see there's no gateway address. Actually, before I configure gateway address, I can show you that in simulation mode so that you see what happens. If we repeat that and look at it in simulation mode, if you do that, the packet, you see the packet goes to the, okay, just let me just send that packet here again. So we want to ping PC1 from PC0. So if you come here and then press enter, the packet is crafted there, then it is sent. It doesn't go anywhere because the PC looks at that IP address and then it sees that it is not in its routing table. And so it is supposed to send it to the gateway address, but there is no gateway address. So it can't send it anywhere. So that is what has just happened. Now let's configure the gateway address for these PCs. So this will be 192.168.1.190. So that is its gateway address. I'll just use the same on the PC, the other PC there. This PC2 is on the same network, so the gateway address is the same. Then when you come to this, the gateway address will now change. Okay. And to configure this guy's gateway address should be .1.126. That is the gateway address for this network. So I'll also copy it for laptop 2 over here. This guy should have the same gateway address. And yeah, so we can go to this other ones here. The gateway address of this PC should be here. Okay. We should have .222. I'll use the same on that other PC3 here. And will be the same thing. And then this guy will have a gateway address of 230.230. And it is the same that this other PC will also use. Okay, so that's it. Now let's repeat that ping from PC0 to PC1. So remember, this is the ping from PC0 here to PC1. That is what we want to do right now. And if you come to command prompt here and let's just you say ping 192.168.1.1, which is PC1. To press enter, let's see what happens. The first packet will be dropped, but then the subsequent ones should be successful. So the reason why the first one is dropped is because it first performs what is called an ARP request to get the MAC address of, in this case, the MAC address of the gateway. In fact, I did say something to you a little earlier that every time a packet goes through a hop, its MAC address gets changed. Or let's say you can leave that one for that other class. Let's just see that one now works. But the question now is this: can the same PC1 ping laptop 0 here? Can they talk to each other? The answer is no. At this point in time, that communication should not be successful. But let's get this guy's IP address. So to get IP address, IP config, and IP address here, that guy is 192.168.1.193. So .1.193. So let's ping that from here. So if you do the ping, let me just move this one up a bit. So you ping 192.168.1.193. That ping should actually fail. And you can see the ping fails. You get what's called, this is an ICMP message that the destination host is unreachable. But can we look at this in simulation mode and see what happens? So if you repeat that ping and we go to the simulation mode here, and then we come back here and press enter, the packet is crafted. Then when it is sent to the switch, as you can see there, then from the switch, it is sent to the router. Then this router, as you can see here, it discards it. Why does it discard it? Because if you look at it, it will look at this destination IP address. the destination IP address, this one, 192.168.1.193. This IP address here. So it looks at this destination IP address that is given here, and it can't find this destination in its routing table. Because it can't find it in its routing table, what will it do? It will drop that packet. It will discard it. And then after discarding it, it will send an ICMP type 8 message saying that the destination host is unreachable. So that telling the whoever was sending that packet that that destination, we cannot reach it. It is unreachable. We don't have the route to that destination. And that is very right, because if you come to and look at the PC1's routing table, if you come to this router 1, not PC1, router 1 here, and this will be Cisco as the password, and then enable, then again Cisco, and then you say show IP route. If you look at this routing table, this router is not aware of that network here, 192.168.1.193. That entry is not in its routing table, and that is the reason it is dropping that packet. Now, there are two things here. I mean, there are two things you can do. Either we configure static route to that particular network, or we configure OSPF. I think in our previous class, in our previous practical, we tried to configure static route. So today, maybe I can configure for you OSPF. Now, OSPF will make these routers share their route information between themselves. So what will happen is that this guy, this R1, will tell R2 about all the routes he is aware about. R2 will also do the same, will tell R1 about all the routes that is aware about. So that in the event R1 has a packet that whose destination R2 is aware about, then he will hand it over to R2, and then R2 will be able to send it. So today, I'm not going to go deep into OSPF. I'm not going to explain, because OSPF is a whole topic on its own. But today, let's configure OSPF. So we're going to do this. Let's start with configuring OSPF on R1. So we say conf t, and then we say router OSPF with a process ID of 1. And then we can give this router a router ID. So router ID of, let's say 1.1.1.1, and then network. So we will let it advertise all these networks here, the three of them. So the first network will be 192.168.1.193. I'm saying three networks. Which ones are those? One is this network. Let me just indicate them. So this router is aware about this network here, and this network here. So we'll let it advertise all those three. And so to do that, you say 192.168.1. We'll start with .0, the one that connects to marketing department, .0. And then here, we don't use 255. We don't use the subnet mask. We use what is called a wildcard mask, because this is 255.255.255.128. That is what otherwise we would have entered here. But just a minute. Okay, so we're saying here, when we're configuring OSPF, you use the wildcard mask. So this one, instead of having that one there, we're going to have 0.0.0.127, because it was 128, the last octet, now it becomes 127. So in other words, we invert the ones to be zeros and zeros to be ones. And then we must specify what's called an OSPF area. So this we're going to have all this in area 0. So that one is done. Now to try and save time. Okay, so I'll just do network again. And another one is now 192.168.1.128. That is the network. And then it is /26. Now this one is going to be 0.0.0.63. Again, is also in area 0. And then the last one, which is network. And the last one is this one here, which is 192.168.1.232. And this is /30. So /30 should be 0.0.0.3. Again, is in area 0. And that's it. So also, we can also say, you can also put a question mark if you don't remember some of these commands, because sometimes it's difficult to remember all of them in your head. But you can always use that feature to help you remember. And one of the things is to configure passive interfaces. So, I mean, explaining some of these things will be too much for you guys at this time, at this level. But one of the passive interfaces is G0/1, G0/1. And another passive interface is G0/2. What we mean by passive interfaces, what we're telling this router, don't advertise OSPF hello packet to this route, to these networks, because they are not connected to other routers. They're just connected to end devices. But on this interface, you can advertise those networks that you know. That is what passive interface means. Okay. So we go to the other router and do a similar configuration. So we come to router 2, and on router 2 here, we're going to advertise again all those routes. Conft, then you say router OSPF with a process ID of 1 again. And then I'll give this router a router ID of say 2.2.2.2. And then we advertise the networks. So the first network, let's start by advertising here, the one that connects to finance department. So that network is 192.168.1.1.192. So 192.168.1.192. And this is /27. That is 2 to 4. So if it is 2 to 4, then that should give us 31. So the wildcard mask will be 0.0.0.31. So how am I getting the 31? The 31, you just take 255 minus 2 to 4 to give you 31. How am I getting 0? Just take 255 minus 255 to be 0. But of course, when you learn about OSPF, you will understand it way better. But of course, in practice, we always say you want to use the shortcut to move a little bit faster. But in simple words, you convert all the zeros to be ones and all the ones to be 0, because 255 was all ones. So if you convert all those ones to all zeros, you get a 0. Then again, they must be in the same area as the other router. So area 0 again. And then the other network is 192.168.1.224. 192.168.1.224. And this is /29. That is 248. So 255 minus 248. That is 7. So that one gives us a wildcard mask of 0.0.0.7. Area 0 again. And then the last one, the one that now connects the two routers. So we also say network, and that is going to be 192.168.1.232.232, and it is 0.0.0.0.3. Area, you must say the area 0. Area 0. This is area 0. This and this here is just the same. Area 0. And in a short while, you'll see a syslog here. Just wait a few seconds. We should see a syslog message showing, telling us that, yeah, exactly, this one. This is what. So now, OSPF has been established, as you can see here. Now, if I scroll up here, look at the routing table here. Now, if I say show IP route again, I expect to see this entry, 0 for OSPF, because we have just configured OSPF. So let's say do show IP do show IP route. And if you look now at the routing table, we have this OSPF entries here. Because we have configured OSPF. So now this router 2 is aware of this network and this network, and it is via these interfaces. You see them indicating via this, and the interfaces are given there. And this one is the cost and the distance, but we can't go into that right now. So now if we come back and repeat that ping and ask, can this guy now talk to this guy? The answer is yes. The ping this time around should be successful. In the event that that ping fails to be successful, then we will have to troubleshoot. Let's do that. Let's do the ping and see. The result of the previous ping, as you can see, they failed. We got this one. Destination host was unreachable. So I'm just going to repeat the same command. So we had ping this host here. We are pinging the same guy here. So if you press enter, let's wait and see what happens this time around. Okay. Seemingly, it's going to fail. So we need to look for where that problem is, because again, you can see, well, so from there, you start going through the trouble of troubleshooting. Okay, let's see the routing table here. Do show IP route. This guy, okay, there's this OSPF entry here to the /27 network. Just one OSPF entry. Okay. Well, we need to look at a few things. Let me see here. Let me start with this one. Do show IP interface brief. Did we configure the correct IP interfaces 234, 222, and 230? What is this guy's default gateway 222, which is fine. Well, now let's see that ping in simulation mode and see if that will help us pick out that problem a bit quicker, because this is okay. Let's see this. Let's just see if we can get that one haraka haraka. Mahali hiyo packet inakuwa drop. So it is leaving the PC, then goes to the switch. From the switch goes to the router. The router sends to the second router. The second router does not discard it. It sends it to the PC successfully. Let's see what the PC, let me just resize here. Okay, let's scroll here. So remember now to a switch. Let's see, it gets the PC and then the PC response goes to the switch. From the switch, it goes to the router 2. Router 2 drops the packet. As you can see, that is what the problem is. So we need to go and look at router 2's routing table because router 2 doesn't seem to know where this network is. This network. So that is what the problem is. So we need to, maybe we configured the OSPF. Let's see, let's look at the routing table here and see if we configured the correct do show IP route and the route to /26 is this one here 192.168.1.128. That route just seems to be fine. And it is via 192.168.1.233. 233 should be this interface here. So let's see if G0 stroke 0 has that IP, do show IP interface brief. Okay, it has that address. Okay, troubleshooting can, let's see if we can have, this is to okay, still trying to see where, why router 2 drops that packet. Uh, okay. Let me try to do a ping from this guy. Do ping 192.168. I want to ping the other interface dot 1.233. Dot 1.233. Yeah, the pings are successful. And if that ping is successful, let me try another ping. Do ping 192.168.1.1. So is able to ping .1.1. Let me do another ping. Do ping 192.168 dot 1.130. Okay. Do ping So from R2, we're able to ping all those interfaces. So from here, I'm able to ping this guy, able to ping this guy. So why then do we have that packet being dropped at this point? Let's see if this guy can we do a ping of 192.168.1.193. Okay, let me try a ping from this guy to that other PC and see 192.168.1.193. Okay, so PC1 is able to ping PC laptop 0 here. Let me see if PC1 will be able to ping this laptop 1 here, this one. The IP address of this one is 192.168.1.225. So if this guy can ping that guy, ping 192.168.1.225. He is not able to ping that. It is destination host unreachable. Who is responding? The router. So that is this router saying that is not able to reach this network here. Okay, let's try to ping this other one here. IP config. That is 192.168.1.194 from here. Ping 192.168.1.194. Okay, so the ping to that is successful. Now we can see this network has some, so as it stands, this guy can talk to these guys. They can talk to these guys, but they can't talk to these guys. So some problem here and there that needs fixing. And as a network engineer, that is one of the things that you will always encounter. Now we need to fix that. We did advertise this. Let me see. To 30. Now, this guy's routing table, let me just see. The routing table here actually has an issue because there's only one entry to 192.2/27, and there's no /29. So we need to configure that. So we need to have it learn that route. Because if you look at this one, we should have two entries in the routing table. So do show IP route. The routing table should have two OSPF entries. Like this one has two OSPF entries, /26 and /25. So we need to say network, and this other network, we need to advertise it. 192.168.1.224. Okay, 192. 192.168.1.224, and it is /29. So for /29, which is 248, that should be 0.0.0.7 area 0. So if I say do show IP OSPF, and okay, let's just check this further. Check this. Do show IP interface no. Do show IP route. There's still only one entry to that particular network. Now, so this guy, this R1, still is not aware of this network here. So the question is, can we configure a static route? Instead of troubleshooting the OSPF one, can we configure a static route to this one and see if it will be added? The answer is yes. To configure a static route, what we do is say IP route, then you give the destination network, which is 192.168.1.224, and then the subnet mask, which is 255.255.255.248, and then the next hop address. The next hop address is the address of this interface here. So that interface address yake is 192.168.1.234. 192.168.1.23234. And that should add a static route. So we say do show IP route. Now there is this static route to this destination here, to this particular